Hi there, Luke McKinney. I'm Course Cram's Physics 117 and 118 instructor. In this video, we're looking at circular motion and how it fits together with forces in order to keep accelerating an object around in a circular path to form a very common physics problem.
We saw that the velocity was changing, and so that means there must be an acceleration, the circular acceleration, or, for its formal name for dates, the centripetal acceleration. And that leads us to the next connection. If there's an acceleration, there must be a total force causing that. Remember, the sum of all the external forces on something is equal to the mass by the acceleration. And that has led to two different types of problems so far. We saw the first type, the sum of all the forces are equal to zero because the acceleration is zero when something is in equilibrium. Or another word for that, constant velocity when the acceleration is zero. Another is when an object's just moving along like a block on a slope and we want to find the acceleration, or if we know the acceleration, to find some other force. So the sum of all the forces is the mass times the acceleration. And both of these problems are done the same way. You just draw the object and the force is acting on it. Let's say there might be weight, normal force, static friction, a classic. And then you apply the sum of the forces in X and Y. Now, circular motion does exactly the same thing. It's just one more type of that. The sum of all the forces is the mass times the centripetal acceleration. So the sum of all the forces towards the center is the mass, speed squared over radius. And from that point on, you just work things out as before. Now, this is called the centripetal force sometimes. Sometimes people call it the centripetal force, or a little more relaxed, the circular force. Now, there's a key thing about this. This is not a new type of force. There's no such thing as an actual circular force that picks things up and spins them around in circles, because we don't live in Skyrim. There's no magic spells that can do that. This is just a measure of how big a force you'd need to hold something moving in a circle. And there's all sorts of examples of that. The most famous, you've got the Earth. Hello. Writing the word Earth is so much easier than, you know, drawing all the continents and stuff. And you have the moon, not to scale. Some people say the moon shouldn't have a capital M, but come on, if my hometown, tiny place, gets a capital, then so does the moon, is what I say. And in this case, we know it's the force of gravity that acts towards the center of, so that must equal the centripetal value. Or if you have a ball and you're whipping it around in a horizontal circle on the end of a rope, then the tension in that direction must equal the centripetal force. But let's look at our equation again, remember. It's the sum of all the external forces is equal to the centripetal force term. So it doesn't have to be just one. It very often is, but there's other examples. For example, if you're going around on a Ferris wheel, so you're sitting there, here's you sitting, red because you're important, hooray. And so you have the weight acting down and the normal force with the seat that you're sitting on pushing up so that you don't fall down. And the center of the circle is below you. So the sum of all the forces in the y direction must be the centripetal force towards the center of the circle. So that's the centripetal force down towards the center of the circle. Remember, in physics, plus and minus are just directions. Plus y is up, minus is down. So the forces are plus the normal force up minus the weight down is equal to minus the centripetal term. And they're a very fun set of questions, definitely ones you'd want to practice before exams with that. You've got ones with gravity, with tension and ropes, with friction and normal forces, but they're all just the same force problems as you have before. You draw the free body diagram, the object with just the forces acting on it. And then just like before, the sum of all the forces is the mass by acceleration. We just remember now there's two special cases. If things are in equilibrium, it's equal to 0. And if it's moving in a circle, then it's moving towards the center of the circle with the centripetal force. So as we saw, that can be plus or minus now going down there. And that's a lovely set of problems there.
Well, I hope that video was useful. What's even more useful is more videos, and you'll find plenty more in the playlists here. But even more useful than that would be a live session with lots of focused practice, the ability to answer your questions, and then doing lots of exam-style practice with focused example problems and full solutions. Because that's what we do at Prep 101. So make sure to join our Prep 101 Study Hub Facebook page, where you'll get details about all the sessions. Some of them are even free sometimes, and other resources that'll help you to do better on your exam.